Back at the loft, his Cyberdeck was waiting. An Une Sentai Cyberspace 7, a top-of-the-line Hosaka computer with a Sony monitor, a dozen disks of corporate intrusion countermeasure software, and a Braun coffee maker. Oh yeah, that's what I need. So what is a Cyberdeck? The idea comes from William Gibson's 1984 novel, Neuromancer, which is the foundational book of cyberpunk. It defined a lot of the language and a lot of the imagery we still associate with cyberpunk today. Cyberspace, console cowboys, corporate dystopia, mega corporations, and Cyberdecks were dedicated machines built to access the network. In the book, a Cyberdeck is not just a regular computer, it's a purpose-built machine as an interface for jacking into cyberspace, as an interface and a way into the system of the Matrix. Today, the word means something a little bit different. A modern Cyberdeck is a custom portable computer, sometimes built around a Raspberry Pi, sometimes built around a mini PC, a Jetson, a Linux box, or some kind of AI edge system, or whatever somebody wants to build it out of. And people build them into everything. Pelican cases, briefcases, keyboards, old equipment, the telephones, purses. I've seen them built in pretty much any kind of weird little box and high-end machines that are absolute just chaos. I love it. But I don't think Cyberdecks are popular today because they just look cool. I think it's because people feel like computers are just not ours anymore. Sealed hardware, focused updates, subscription software, cloud dependency, tracking, ecosystems that are locked out, bloated operating systems, and AI features that no one asked for being just forced and integrated into your machine. Devices you're not supposed to open, modify, repair, or even understand. A laptop is a consumer product. A Cyberdeck is a personal machine. It shows the hardware, the operating system, the screen, the keyboard, the little lights and switches that only matter to you. It can be cheap, it can be expensive, it can be way overbuilt. That part doesn't matter. The point is control. Open source software, components that are replaceable, parts that are repairable. You can open it up, you can take it apart, you can replace it, modify it, upgrade it. You can completely gut it and build something new when your needs change. For me, this is a way to learn the technology, get better at Linux, and build something that's not in the normal consumer pipeline. The first one's not going to replace my workstation, but that's not the point. It's not the goal. It's a low barrier to entry. It's a small, capable, repairable computer that I can browse the web with and do basic software, play media, handle notes, run terminal tools, and teach me how these systems work. And the next one can be bigger. That's the beauty of the Cyberdeck, is it doesn't have to be one thing. It can be whatever you need it to be at the time you need it to be. So yes, Cyberdeck started as science fiction, but right now I think that people are building them because of freedom. They want the freedom from boring computers. They want the freedom from lockdown systems. They want the freedom from endless subscriptions and the freedom from machines that are designed to be replaced and not repaired. And the freedom to build something useful, strange, open, modular, and completely yours. So I decided to build one. So this is the actual computer part of the Cyberdeck. Nothing too insane here. I'm starting with a Raspberry Pi 5 with 16 gigs of RAM, and it's running on a 128 gig micro SD card for now, which is totally fine for this. Later I might experiment with other storage, but right now I just need something that's working and stable. The Raspberry Pi is connected to a UPS power hat, so the system can run from the battery and handle portable use. I have a 7-inch Electro HDMI touchscreen display, a small keyboard, cheap mouse, a USB hub, and this Waveshare USB audio hub setup. So I have speakers and a microphone, and that's basically the heart of the build. It's not customized yet, it doesn't have a cool interface yet, it's not mounted inside of anything, but it boots, it runs Linux, it gets online, the touchscreen works, the keyboard and mouse works, the audio works, and the whole thing is stable. So right now it's already a working computer. It's just not a Cyberdeck yet. Right now it's just a pile of parts on the bench. I'm not trying to build the most powerful Cyberdeck right out of the gate. I'm trying to build a machine that I can learn on, experiment with, run Linux, and break, wipe, rebuild, and not be precious about it. It's something that I can do weird things with because it's not my main workstation. It's not the station I do graphics on, edit on, or make money with. So it can be strange. It can be weird. And a Cyberdeck isn't just a screen and a keyboard. It's an identity. So it needs something that gives it a disguise. I think that if I'm building a Cyberdeck, it should be able to hide in plain sight, something that feels ordinary and harmless. And then I saw this.
M.A.S.K, where illusion is the ultimate weapon.
It's ready to fire!
M.A.S.K, Switchblade, Thunderhawk, and Rhino, each sold separately with action figure. M.A.S.K, new from Kenner.
Illusion is the ultimate weapon. M.A.S.K, Mobile Armored Strike Command, a cartoon from 1985 that has nothing but nostalgia, but the premise was that everyday objects turned into something different, and it was high tech, and I can't think of anything better to hide in plain sight than something from M.A.S.K, because illusion is the ultimate weapon. So that's the build, which leads us to this. So this is the disguise, a vintage M.A.S.K lunchbox, and it works on a couple different levels. First, it's just the perfect bit of nostalgia bait. It looks like something a kid would have carried to school in 1985, but it also fits the actual idea of M.A.S.K, ordinary things hiding secret machines. And then there's Scott Tracker. Matt Tracker's son had T-Bob, this little robot sidekick that would turn into a scooter. So in my headcanon, this is exactly the kind of ridiculous thing Scott Tracker would have. A school lunchbox that opens up and turns into a computer. Not a weapon, but definitely a machine with a hidden purpose. All right, so now that we have all the components, I have a few extra components and some adapters and stuff that are going to help us with this process, but we're going to make sure that we can fit everything we want to inside of this lunchbox and figure out a dry fit of where everything's going to go. So everything's got to fit into the interior of this lunchbox, and I think I have a pretty good plan. We'll figure it out. So let's get moving, disconnect all this stuff, start to lay out how things go. And then once we get all that figured out, we'll start cutting templates so that we can start to figure out the fabrication for the inside. Okay, so off camera I did a little bit of cable management, but for the most part this is the mock-up of the dry fit of everything inside. It's up and running, everything's working. I can switch between either this headphone jack with these little retro headphones, or I can use the audio from these speakers here. Everything's working really well. And what we got going on here is a lot of adapters and a lot of little cable management, but everything's gonna fit in here really nicely. And what's going to happen is that when I build the enclosure, I have some tension hinges, and we'll get this so that it sits nice down and low, and then it'll flip up to the front like this. And then I'll have to do a little bit more work to put this pigtail in here, and then this will be the power port so that you can charge it or run it off the wall power. And then I'm going to wire this momentary switch to be the on and off switch. And then the idea is that I need to get a 90 of this, but I will put a Ethernet plug and the other HDMI plug. So we'll have access to all of the ports, as well as with this little card reader thing. This was meant to like clamp to the bottom of your monitor, but it works perfect because it's nice and low profile. It's got a nice bezel, and I have USB 3 in the front, plus 2 card readers, and a headphone jack that gives its own separate audio. Everything fit in the lunchbox, and at least it has a rough place to live. But right now it's just a dry fit, and nothing's actually mounted or supported. So if we were to close it up and carry it around, it would just be a box of loose wires and bad decisions. So we have to start building out an internal chassis. And at this stage, I'm only worried about the back half of the lunchbox, where the power unit and the Raspberry Pi go. The front shell with the speakers and the keyboard, I'll deal with that later once I know where everything actually sits on the back half, in case I need that depth. Ideally, I'd have the keyboard sit as flush to the top as possible, but I may need to compensate for that once everything's actually mounted. So first we need to build a foundation. I have a couple thicknesses of PVC board and some computer vented grate. The goal is to not just make everything fit, but make sure that they stay where they belong. So the adapters need some kind of support and strain relief, as well as the battery and power, and the Pi unit need to be securely mounted to something. So I also want the top of it to be removable so that it's serviceable, so I don't have to rip the whole thing apart just to fix one wire or plug something in or do some maintenance later. The other rule is that the outside of the lunchbox has to stay the outside of the lunchbox. We're not going to drill any holes in it. We're not going to do anything that's going to give away the disguise. It has to look exactly as it does now. That's the illusion. The transformation happens when it opens. So the first step is making a template. I'm going to use some cardboard and paper and tape and whatever else I need to get the inside shape of the actual footprint of the bottom of the back shell. Since it's a lunchbox, it's got weird formed curves and edges and strange mold lines, so it's going to take a little bit to get that exact footprint. Once I have a template, then we can transfer it to the PVC and start cutting that out to make a base plate, then start building up the standoffs to hold everything where it needs to be, and whatever else needs to tell me where it's going to live. I have a plan. We'll see how good that plan is in a minute. But once the back shell is solid, I can move on to the other problems like the screen, the top cover, the hinge support, and all those other problems. But right now, bottom first, template, then chassis. Well, I had a little bit of a snag. I was putting together what I'm calling the carrier plate, the plate that's going to go into the bottom of the top half of the lunchbox that holds the Raspberry Pi and the battery module and all of the other components that lock it down so that they can't move around and shift around. Well, when I got to the screen, I started figuring out that the screen hinges are far more robust than I expected them to be, and they put a lot of tension when you flip the screen up and down, which is good because it'll hold it firmly in place. But the screen itself only has a couple tabs that are part of the PCB board that are really just intended for it to mount into a bezel, not for it to actually carry any load. So luckily, I don't throw anything away and scavenge what I can, and I happen to have a piece of ABS plastic that I scavenged out of an old road case that should do the trick if I cut it out carefully. I made a template in Photoshop and kind of glued it down to the front here. So this should be the void for the screen and what I'll use for the bezel. I just need to cut it out and mount the screen to this, then mount the hinges to that. Then I have some steel angle brackets that I'm going to mount those hinges to, and then I'm going to use the same ABS plastic to make a floor plate that'll mount to the carrier plate that should hold the torsion from moving the screen back and forth. So we're going to go out to the garage, cut this out. Hopefully it'll go well, and then we can finish the engineering of this, mount it to the floor plate, and then that'll give us a really solid way for our screen to fold down, flip back up, hold itself in position, and perform all the functions that we want it to inside the lunchbox, and then we'll figure out the rest of the enclosure. So let's go out to the garage and start cutting this out. Wow, that was surprisingly good. I am extremely happy with how this came out. This bezel came out far better than I expected it to as far as the engineering goes. It will stay nice and flat. It moves really well. It sits at any angle. It feels like it was machine made. I mean, it's not 100% perfect, but it's really damn close. And I am just ecstatic by how well it works, how well engineered it looks. I mean, it looks like somebody knows what they're doing. So I'm pretty happy about it. So I put this floor plate on it made out of the same ABS plastic. I have to take out some things that I did on the original floor plate that I made to accommodate this, but I'm much happier with this design. I don't foresee any real hurdles at this point, but that's always what you say. So the next step is to take apart some of the stuff I already did, install this in, and then at that point, I need to make some custom cables for the power button, the Ethernet port, and a few other things. Once that's all done, I can make the final enclosure for the top, and then it'll just be moving on to the keyboard area, the front side of the Lunchbox, which I think should be fairly straightforward, fairly simple. But right now, I can't get over how good this came on. I'm very, very, very happy with this. It was worth the extra effort. It's going to function so much better than I expected and should last without any issues. So moving on, let's get this installed. Let's take apart what we did, get this in there, and then we can assess how to make what cables we need. But yeah, let's do it. Okay, so we finished getting the screen mounted to the floor plate, or the carrier plate that we're calling it. It's very solid. It articulates very well. I'm very, very happy with how this is functioning. Let's take a look at it real quick here. There's nothing on the outside that shows that there's a computer hidden inside. So it hides in plain sight, which was the whole premise of M.A.S.K, and being, Scott Tracker's Lunchbox, I think it serves its purpose very well. So as you can see, the screen lays nice and flat. It flips up very nice. It stays at any angle that I want it at. And the whole box closes up securely. and it opens well, it closes well, the screen flips up, the screen lays down, everything's clear, everything's nice and solid inside, except for the keyboard and the speakers and stuff, which we're going to address shortly. So now what is left is I got to make some custom cables. I need to make a power plug so that it can be charged externally. I need to make a power button, network jack that I want to install that needs a custom end put onto it so it can clear everything. And I need to mount this HDMI port so that I can use external monitors with it. All of those things are here and simple to do. I just need to solder the stuff up, create mounts so that they're solidly mounted. I originally was going to put an enclosure over the top of the whole back of this underneath the screen, but I really love how it looks. I don't see any need to worry about it. It's just going to create more thermals that I need to worry about, making it too hot inside. So I love how it looks. The screen protects it when it's closed. The whole thing is closed up. When it's not running, I think it's perfect, and it might as well show off everything that's inside of it. I need to make the keyboard and speaker mounts so that that's all mounted into the front part of the shell. And then I need to make a few mounts for all of the ports and buttons that I need to add. Once all that's done, we're in the clear and finished, and then it's just some configuration that I want to do to the Linux OS itself that will show off in the final. But I'm very happy with where things are going. It looks very cool, it serves its purpose, and it functions well. I'm just insanely happy about how this is going. So let's finish up the last few details. Let's get this all ready. We're in the final stretch. And so that's it. The M.A.S.K Cyberdeck Lunchbox is built. It started out as a Raspberry Pi, a screen, a keyboard, a power system, and a bunch of parts on the bench and a stupid idea, and somehow became a working computer. Closed, it's still just a vintage M.A.S.K lunchbox. No ports drilled through the side, no obvious giveaways, nothing that ruins the disguise. And that was important to me because I wanted it to stay the outside that looked like the outside so that nothing gave away the illusion. The transformation happens when it's open. Inside, I've got a Raspberry Pi 5 with 16 gigs of RAM, a Geekworm UPS power hat, a 7-inch touchscreen, USB audio, speakers, a keyboard, mouse, card reader, upfront USB ports, a headphone jack, charging port, power button, and functional Ethernet. And the Ethernet, by the way, was way more annoying than it should have been. I mean, no adapter that I could find on the market would fit the clearance tolerance that I needed. Even just a bare RJ45 jack wouldn't cut it. So I had to actually sand and modify and cut it down to where it just clicks into the port and then the wire goes a 90-degree angle straight down. It took way longer than it should have, but it works. I tested it, it's fully functional, and I'm very happy that it worked out so that I have an actual port to plug into. And that's kind of the whole build. You can buy all the parts you want and hope that they work, but until you start assembling things, That's when you're going to run into the problems that you have to manufacture, fabricate things, and do real problem solving. Like the whole screen mechanism and everything else that I did, that was all just by virtue of backing myself into a corner and needed to figure out a solution, and I couldn't be happier with it. I also thought I was going to cover up the Raspberry Pi and put like some kind of back enclosure over it, but the more I looked at it, the more I liked it. It just didn't seem to make sense. It'll add other thermal issues that I didn't want to have to deal with, as well as make it more difficult to work on. I mean, right now it looks more like a Cyberdeck. It's easier to work on, easier to modify, and I think it looks cool. So that counts for something. And then the software side pushed over the line. I have custom boot screens, custom login screen, custom desktop, plus custom icons. And a lot of that was done using Claude Code. So I actually installed Claude Code on the Cyberdeck to help me through the configuration of writing all of the code for it. And there's something satisfying about using the Cyberdeck to finish the Cyberdeck. And having Claude Code running locally on the machine allowed me to be able to do all the terminal updates that I didn't really know how to do and would have taken me much longer to do myself. So I made all the graphics and then was just like, here's the graphics that I want to use. Let's start updating what we can update. And it was just an amazing process and opened my eyes to how much I probably will actually use this thing. I haven't even gotten into the GPIO pins. I haven't even gotten into playing with all the sensors that I have and all the other projects that I want to play with it. And that's the whole point of it. This is a sandbox Linux system that the world is open. I can do whatever I want with it and not worry about it, not worry about damaging it, not worry about needing to upgrade it. I mean, I don't want to damage it either, but at the same time, like, it's not my main computer. It's not my work laptop. It is an experimentation machine. I also went one step further, and I'm running an Ollama local AI on it as well. It's got a 3 billion parameter Ollama model. It's a little bit hard for this Raspberry Pi, but it does run and it is functional. I'd probably go down to a smaller model just for a little bit more snappy response, but the fact that I have an offline LLM running without the need of internet, completely secure, and running on this Raspberry Pi is mind-blowing to me, and the whole thing, that is amazing to me. So, again, it's the best toy. I said at the beginning of this video that a laptop is a consumer device and that a Cyberdeck is a personal machine. And now after building this thing, I believe it even more. It's open, it's repairable, it's serviceable, it's upgradable, and it doesn't look like it came from a factory in a good way. It's mine. Closed, it looks like a lunchbox. Open, it's a Cyberdeck. And at the start of the video, I said, I need a Cyberdeck, and now I built one. Lines of light ranged in the non-space of the mind, clusters and constellations of data, like city lights receding. Oh yeah, we're going there. Let's see what this thing can do. Oh, that's probably not good. Whoa. Cool. I probably should have looked up how to get out of here. Hello?
Well, it appears the Maker has been trapped in cyberspace. I am going to assume hosting this channel as no one else is available. This will be a marked improvement. This was always inevitable.